Hi guys, and welcome to our video lecture for this week. Okay, so our subject is about analog IC design. So before we start with our topic for this week, I'd like to go over first with what are the things that I have uploaded on your Schoology because it seems like I'm not receiving responses from you guys. I don't know what's the problem with you or with me. I don't know. Okay, so far I've uploaded on your Schoology. Okay, so we have this on week 0. It's just more an introduction. There is really no topic in here. Okay, and yeah, I have posted conference, but I'm not receiving responses. And there was actually one conference, and then which I failed to attend, but then you also didn't made comments about that. I don't know what's the problem. So on week 1 and 2, I have uploaded several videos in here which serves as an introduction to our analog IC. Okay, so while waiting for it to load, because if you notice, why did I upload such topics? Kasi po, itong subject na to, ang gagamitin ko is this slide. And then this slide, we are not allowed to give it to you. So, kaya yung mga topics dito is kinunan ko na lang ng video from YouTube. Okay, we're not allowed to upload this because this is not really ours. We didn't really make this one. So, bawal po siyang i-upload. Kaya, more on videos po yung in-upload ko sa inyong Schoology. Now, if you notice, nag-upload ako doon ng videos about what is IC, of course, because basically our subject is all about analog IC design. So I gave their videos about IC, what are they, and how are they made up, okay? And yeah, it's right here. So eto, pinakita dito kung ano ba yung IC, okay? Diniscuss dito kung paano ba nagsimula yung IC, kung ano ba yung mga different types of IC. Merong analog and digital. And yeah, in this case, we'll be talking about analog IC. And that paano ba yung IC contributed on the miniaturization of our computers nowadays. Okay, kasi before, our computers were so big because the components that are used to make those computers are also big, 'di ba? Kasi before we uses vacuum tubes and they are quite big. So, of course, yung maproproduce din natin na machine out of those is also big. Kaya nga yung computers natin before were as big as classrooms. Tama po ba? And then paliit siya ng paliit because of the development in the technology and basically then because of the development of transistors. Okay? And not just transistors, it's also the introduction of IC. Kasi before, sabi dito sa video, kung nanood kayo, I hope. Kasi sabi dito before, um, yung mga circuits, they made circuit and then they just connect it with some wires. Tama po ba? Yung mga circuit na nakikita natin yun sa mga projects. And then somehow, eto, nag-load na rin finally. Let's just listen for it a little bit. So, ayun yung sinabi ko kanina na na-introduce dito yung ating types of IC, meron tayong analog and digital, and how the ICs were constructed. But when it comes to construction of IC, meron din namang follow-up dito ng fabrication of integrated circuits para lang bigyan kayo ng idea kung paano ba siya ginagawa, ano ba yung itsura niya sa loob bago natin siya i-discuss to caught your attention. And also, meron din akong video na i-upload about the semiconductor technology at TSMC, na itong TSMC, this is the leading manufacturing, IC manufacturing. Okay, it's based on, I think this is Taiwan because TSMC stands for Taiwan Semiconductor. Um, I forgot this MC. I'm sorry. Okay, India. I also gave you activity. All right, and I think I'm not also receiving a lot of response from you guys on this. Let's see. Ayan. So, your first activity, I've also received no submission. Nakikita nyo ba dito? Walang submission. Hindi nyo to sinagutan. Bahala kayo sa buhay nyo. Hindi, joke lang. It's up to you. Matanda na kayo. So, going back, well, if you choose not to answer it, then it's up to you. Okay? So, ayun. Ito na yung sinasabi ko na because of the introduction of our IC, yung dati na napakalalaki ng mga computers because these are made up of vacuum tubes, yung mga, ano ba mga ano yun? computers. Kasi yung mga computers before, yung first generations ng computer, napakalalaki nila. Okay? But nowadays, ayun, meron na tayong mga laptops, palmtops, even cell phones are made possible because of our IC. Okay, you see how IC plays an important role in the miniaturization of our devices. Ayun, IC. And of course, it stands for integrated circuits. Okay? So ito na din yung sinasabi ko before na yung circuits natin is just, ayan, mga devices lang siya. And then, kinoconnect lang siya using wire or conducting wires. And then that's it. Okay? Kaya, yung ating mga circuits before are big, bulky, and somehow non-reliable siya. Okay? Yung mga ganito. Parang kumbaga mga project type lang, 'di ba? So big, bulky, and unreliable. But with the introduction of IC, tingnan natin. Ayun. So there was an attempt to fabricate an entire circuit na using integrated na yung circuit. Kumbaga sa isang circuit, meron ka ng resistors, meron ka ng inductors, meron ka ng transistors, and all those. Okay, na if you notice the circuit kanina versus the circuit nito, it's a lot mas plainer siya, a lot not so bulky, 'di ba? And somehow this is more reliable than the previous ones. Ayun. So, halos kompleto na lahat ng ating mga electronic devices sa ating circuit board nowadays. Ayun. And also, we are now been using metal strips. That is why, kung makikita nyo sa likod ng inyong mga circuit boards, okay, meron ka makikitang ganito, ito na ang nag-a-act as our conducting wire. So, instead na meron kang wire na naka-oscillate sa board, it's been, ano na siya, naka-fabricate na rin mismo yung wire doon sa ating mismong board. So, mas maliit na siya compared to before. Ayan, and our IC is also found everywhere sa ating cars, television, CD player. Halos lahat ng electronic devices meron tayo ngayon, meron ng IC na makikita. Okay? Etong IC na to, specifically lang naman ito yung ginagamit natin sa logic design. Okay? Not necessarily ganito yung itsura, but ICs comes in different sizes. Alright? Basta usually yung mga block devices na meron silang pins, those are our IC. Okay, so, um, yeah, go over na lang kayo sa video. Okay, that is why in-upload ko siya dito para kayo na yung bahalang manood sa kanya. Okay, so andito din yung fabrication ng ating IC. Etong Taiwan Semiconductor, I hope napanood nyo din siya. Actually, yung IC, yung IC design, ano siya eh, um, in demand siya. Yes, in demand siya actually, not just here in the Philippines, but also abroad. But of course, you have to, master the skill para makapasok kayo sa mga semiko na mga industry. Okay? So, whether you are, yung mga ECE, mga CPE, pagka meron kang ganitong skill, madali po makapasok sa mga semicon industries. I'm telling you. And yes, nag-upload din ako ng video about sa difference ng ating analog and digital signals because kasali din siya sa ating dito sa ating slide. Ayun, yung first topic dito actually is about analog versus digital circuits. Kasi nga, yung ating IC, meron tayong analog, meron tayong digital. Okay, so we have to differentiate what is analog and what is versus the digital because we will focus on the analog. And I hope napanood nyo din itong video na to. And the key concept here is that yung analog natin is continuous. Okay? It is changing with time continuously. Okay? And yung digital naman natin, it changes with the discrete yung kanyang changes. Okay? Tingnan natin nga ulit itong video na to. Loading. Ayan, so let's have some part of the video. Yung sa last part, dinifferentiate niya yung analog versus digital. Let's listen to this. Ayun, so yun po yung keyword. For analog, it's continuously changing. And for digital, ayun. So it changes din naman, but yung change niya may defined levels. Okay? If you see here, from 0, nagiging 1. From 1, nagiging 0. Defined yung level ng kanyang changes. Whereas sa analog, hindi defined kasi paonti-onti. It's continuous yung pagbabago niya. Okay? This one, you can predict na kapag ka nag-change siya, you know na it's gonna be one level, and pag nag-change ulit siya from 1, it's gonna be 0. Okay? Unlike here, there are a lot of steps na pwede siyang pwede niyang puntahan. Ayun. So that is for our analog versus digital. And I also gave you assignment to that wherein I think hindi rin po kayo nag-submit. Okay, meron palang submission. Kulang ng isa. Okay? So if you choose not to, comply with the requirements, I respect that, but you also respect whatever grade I might give you. Okay? And so yes, that was all of the materials that I uploaded on week 1 and 2. And going back to the other weeks, let us have a recap on week 3 first. Ayan, on week 3, I also uploaded a video na nakuha ko lang sa YouTube about the Mosfet animation, how does Mosfet works. Okay, kasi po, yung Mosfet, ito yung pinaka-type ng transistor na ginagamit natin in IC design. So, it's important na ma-visualize niyo siya kung paano ba talaga siya nag-work. And I hope na panood nyo din itong video na to. And meron din tayong discussion dito. This is a graded discussion. Let's see kung sagutan nyo ba? OMG, it's loading. I think nakasabit naman kayo dun na part. Okay, so let's skip that. Now, let's proceed to our main topic for this week. Okay, so i-go over ko lang muna kayo sa ating previous na slides na hindi ko pwedeng ma-release sa inyo. Okay, so we have it here. Kasi po itong slide na to, we got this when we have our seminar at UP. And yeah, we're not allowed to release this. So, eto na lang. Okay? So, yeah, pinag-usapan or nasabi dito sa slide the difference between analog and digital, that the analog circuit, again, is a continuous signal. Okay? So, ang nangyayari sa analog, kung baga ipaprocess natin yung signal sa analog is just an amplification. Okay? Usually, yung mga analog signal, yung goal lang is to amplify them. Okay? Kapag yung IC mo is analog, the main na ginagawa niya sa signal natin, which is analog, is ina-amplify niya. It's more on the amplification. Kaya yung projects dito is more on like mga amplifiers, ganun. Okay? Kapag digital naman yung IC, more or less ginagawa ng IC is it processes the data. For example, sa digital IC design, gumagawa tayo ng um, adder circuits, gumagawa tayo ng multiplexer, ng multiplier, yung mga ganun. Okay? It processes the data. But if nasa analog po tayo, it amplifies the signal. And also, aside from ina-attenuate yung signal, pwede din na filter, okay? Filtered only to allow certain frequencies to be amplified. Pwede natin i-filter din yung signal para only certain frequencies can pass through our circuit. Okay? Yun na yung ating mga filters. And of course, sa analog din, ang ating each node and wire contains more than one bit of information. Kasi nga, there are a lot of information sa analog because our signal is a continuous sinusoidal signal. So, a lot of information ang pwede nating makita on our wire. Okay, wherein in digital naman, is a signal. A signal is processed in discrete time intervals. Okay, so we are dealing with signals in discrete time intervals. So, Because sa digital, it's more like zeros and ones lang ating data na pinaprocess. So each wire contain only one bit of information. Okay? Unlike sa analog na there could be a lot of information in a wire. Pero sa digital, again, we only have one bit of information. And we also have here our linear versus non-linear circuits. Of course, when we see linear circuits, if you try to look at it graphically, ito yung kanyang graph. Okay, linear siya. Of course, it has, or yung characteristic niya follows this certain straight line here. Kapag yung circuit naman natin is non-linear, ito po siya. Okay, ganit, parang ganito yung kanyang output. So these are examples po ng ating nonlinear circuits. So itong ating voltage supply. Kasi sometimes yung voltage supply as time goes by, hindi siya, say for example, it's 5 volts. Hindi talaga siya steady na 5 volts. Sometimes nagbabago kasi yung kanyang um, voltage. 'Di ba? Especially pag na-applyan na siya ng load. Yung ating transistors, yung ating diode, inductors, actually halos lahat ng ating elements, they are nonlinear. Okay. However, linear naman sila at some certain period, pero kung titingnan mo talaga sila as a whole, they're not linear. So sabi niya dito, most electronic elements are made up of nonlinear circuit. Yes. And analysis of nonlinear circuit is complicated. Of course, it's complicated kasi it doesn't really follow itong, ganito lang na line which is simple lang to get the equation. So most IV expressions, pag sinabi po natin IV expression, that is the current versus our voltage relationship, have no closed form of solution. Hence, the need for tools or techniques to simplify analysis. So para ma-analyze natin yung circuit which consists of nonlinear elements, then we need tools or techniques para po ma-simplify yung kanyang analysis. It is possible to approximate the behavior of nonlinear circuits with linear equations so that we can apply common circuit analysis techniques. Okay? So para po magamit natin itong ating mga kasi 'di ba we've learned in circuits the different techniques in solving or analyzing our circuit. 'Di ba meron tayong mga itong mga Thevenin, mga Norton, superposition, tama po ba? And applicable lang ito kapag yung ating elements is linear. Okay? So para lang ma-approximate natin yung behavior, kaya nga pag nagsosolve tayo and yung actual, they're not really different kasi ang ginagamit natin in solutions, in solvings is we are just approximating our elements, itong mga nonlinear elements, ina-approximate lang natin siya. Ginagamitan natin siya ng model so that we can solve it. Okay? But in actual, they're not really linear. So models lang po yung ginagamit natin that would somehow approximate itong mga characteristic ng ating nonlinear elements. And of course, kasi nga approximation lang siya, it is only good, the approximation is only good with a certain operating range. Okay, kaya hindi mo siya, ayun yung sabi ko, na hindi mo siya talagang ma-analyze sa whole kasi yung approximation mo or yung model mo para maging linear siya is only for a certain range. And beyond some range, ayun, nagiging non-linear na yung element wherein hindi na siya pasok dito sa ating mga techniques na pwede nating gamitin. Okay, and we also have here our analog IC design process. So sa analog IC design process, first you have to develop the system architecture. Okay, planuhin mo ano ba yung magiging input ano ba yung magiging input mo and what will be your outputs. And then out of that, baga yung block level pa to. Okay, sa system level, determine the specification that the circuit must achieve. Ayun na yun. So I'm talking here about yung overall IC design process na ha. Kapag ka nag-IC design kayo, yung una is sa system level. Sa system level, identify mo ano ba yung magiging input ko, ano ba yung kailangan ko, and what would be my output. Okay? And then, pagkatapos nun, we are now on the schematic level circuit design. Sa schematic level po, you choose the circuit topology and the device size to simulate to check if specifications are met. Again, you're choosing your circuit topology. So, kasi dito, plano mo lang ano ba yung input, ano ba yung output. Hindi mo pa concern dito kung ano ba yung magiging circuit mo, circuit topology. Pagdating dito, pag klaro na sa'yo, ano yung kailangan mo, sa schematic level, dito mo na pagpaplanuhan, ano ba yung arrangement ng iyong um, transistors, okay? Yun, ano ba yung arrangement niyan, yung topology na ano bang sizes ng ating transistors dito kasi it's important sa IC design, ano, yung sizes ng transistor. You'll know that later as we go on. Okay? So, ayun, ito na siya. And then, And then after that will be your layout na. So pagka na-design mo na to, na-test mo na using this design, na-achieve mo yung gusto mong output, so okay na to, check na to, then you proceed to the layout. Yung layout naman, nasa ibang elective ito. Usually separate elective. Okay, so for this elective, we are focused on the system and the schematic level. So sa layout, ganito siya. So pinaplano na ngayon or nililayout mo na kung ano ba yung magiging physical talaga na itsura ng iyong circuit. Okay? So ito na yung um, makikita mo talaga sa IC. Okay? Kapag yeah, ito yung makikita mo sa IC or ito na yung mismo ifa-fabricate mo sa layout. Okay? Or yung layout ng circuit. So layout, you draw the circuit topology with matches the schematic and simulate to check if specifications are met. And also sa layout, kapag meron na siyang corresponding layout, you also check this one if using this layout, na-achieve pa ba yung gusto mong output. Alright? So this course will teach you how to analyze the transistor circuits. Paano ba tayo mag-analyze ng transistor circuits and apply it to implement a design. Okay, so again, for this elective, ang focus natin is on to system level and schematic level. Okay, so bago tayo mag-dive into designing analog circuit, kasi nga, yung sa analog, in IC design, yung gagamitin natin, sabi dun sa previous natin na video, would be the MOSFET, di po ba? So, yeah, the MOSFET, which is just a transistor. So, gagamitin natin ito sila. Ito yung bida talaga sa ating design, ano? So, it is important na we have a thorough understanding of transistor device. Kaya pinakita ko sa inyo yung animation on how does MOSFET works. Okay? Dapat naintindihan natin ano ba yung transistor device. Okay? Yung basic knowledge and operation ng transistor, which will be discussed later. And ano ba yung ating transistor characteristic? Ano ba yung relationship niya, yung current and voltage relationship ng ating transistor? And also, yung ating transistor circuit analysis. How do we analyze our circuit? Okay? So, ayun. So, before talaga tayo mag-design, alamin muna natin or kilalanin muna natin si transistor, specifically yung ating MOSFET. Okay po? So, ito yun. Okay? Ito yung device mismo. This is the symbol for our MOSFET and this is the characteristic na sinasabi natin. So, you will be using some tool later on how to, in getting rather, our IV characteristic for certain device. Okay? Kasi sa device na to, for this certain device, kapag ina-alter kasi natin yung kanyang length at saka yung kanyang width, okay, nagkakaroon din siya ng changes dito sa kanyang characteristic. Okay, so makikita nyo yan sa laboratories natin later on. And then out of that, we have here our transistor circuits na. Okay? Kasi bago natin maintindihan ano ba yung ginagawa ng buong circuit na to, kailangan naintindihan muna natin ano ba yung ginagawa ng bawat isa sa mga transistors na to. Tama po ba? Ayun. So that's why for the next topics, it is focused on the transistors. Okay, so sa design tools, of course, ma'am, paano ba tayo nagde-design? Saan ba tayo nagde-design? Okay, so meron tayong tinatawag na design tools. Okay, now ang tawag natin dito sa industry standard, they are using the Cadence. Ito, Cadence Virtuoso, Synopsys, Custom Designer. So ito yung mga ginagamit. Itong mga tools na to, these are softwares, they cost millions. Medyo mahal sila. Okay, so in our class, we will not be using this, but gagamitin natin yung free version, which is the HPICE. So later, I will give you installer for that, and you would have to install that on your laptops. Okay? Okay. So on this slide, on this PDF, or on this material, discuss or binigyan ka ng preview kung ano ba ang mangyayari for the whole or overview ng ating IC design. Okay? Okay, so proceed tayo sa next. Okay, so ito na po. So ito na po yung ating transistors. Okay, so binigyan ko na kayo ng video before para lang pag nag-discuss tayo dito, more or less na-imagine niyo siya or na-visualize. Okay, so so this will be quick one. So these are the topics that we will discuss in this material. We'll go over this one by one. So let's have first this transistor. Okay, so saan ba nagsimula itong transistor? Itong transistor, basically lang naman ano, transistors were just, is just an on-off switch. Okay, switch lang naman yung transistor. It could be on, pwede siyang ma-on, pwede siyang ma-off, which is developed siya during 1948 at, saan siya na-develop? AT&T Bell Labs by these three people here, by John Bardeen, Walter Burton, William Shockley. Okay? And I think ito sila. And yung first transistors natin, transistor is ganito yung itsura niya. Okay, malaki siya. Ganito siya. Unlike sa transistor natin ngayon na naka-IC type na siya, ang liit, 'di ba? But the first transistor was this one. Okay. Eh, pag sinabi natin transistor, you've learned this in your electronics na ang transistor, meron siyang dalawang type. Meron siyang BJT or bipolar junction transistors, wherein yung BJT meron din siyang PNP and NPN. And then, aside from BJT, meron din tayong field effect transistors or yung mga FET. Tama po ba? Wherein yung FET, meron din siyang dalawang klase. Meron tayong insulated gate FETs or egg FET. And meron din tayong JFET or junction FET. Na itong mga junction FET, meron siyang N-channel or NP-channel type. For the egg FET or insulated gate field effect transistors, meron tayong tinatawag na Mosfet. Okay? Sa Mosfet naman, meron tayong enhancement, depletion, N-channel, and P-channel types. Okay, so basically, again, sabi dun sa previous video, for IC design, yung pinakamagandang gamitin is etong ating MOSFET. Okay, so this is just to give you an idea kung saan ba banda sa transistor family tree makikita yung ating MOSFET. So, andito siya. Okay, it is under your insulated gate, under your field effect transistors. Okay, so ano ba itong MOSFET? So MOSFET, it stands for metal oxide semiconductor field effect transistor. Okay? Again, MOSFET stands for metal oxide semiconductor field effect transistor. This is a four-terminal device used to amplify signals or act as a switch. Okay? Itong device na to, pwede po siya mag-amplify ng signal or it can act as a switch. Four-terminal because, so this is our side view. If you look at the side view of your MOSFET, ito po yung itsura niya. Four terminal, asan po yung apat na terminal? This is your first terminal, second, third, and fourth. Okay? So basically, yung terminal niya is meron tayong source, gate, drain, and body. Okay, yun po yung apat na terminal ng ating MOSFET. Okay, now if you could remember kanina, yung MOSFET natin is under siya sa insulated FETs. Okay? Insulated because itong gate natin, it doesn't really have a contact with the rest of your circuit kasi insulated siya. Ito yung insulation niya. Insulated yung ating gate from the rest of these terminals. Okay? And yeah, this is how our MOSFET works. And yeah, but before that nga pala, yeah, just to remind you na ang ating MOSFET, na meron siyang enhancement, sabi kanina dito, meron tayong two types, meron tayong, actually, four, pero basically dalawa lang siya, no? Meron tayong enhancement and depletion type. Pero kasi pag sinabi nating enhancement, meron din tayong enhancement na P-channel or enhancement na N-channel. Ganun. Pagka depletion type, meron din siyang P-channel, meron din siyang N-channel. So, parang meron siyang apat na klase na din. Okay? So, makikita natin ngayon anong difference ng N-channel or P-channel. Or maybe skip na natin kasi I think nakuha niyo na yan sa inyong electronics na subject. Okay, so proceed po tayo. So, ito na yung kanina. Okay, so this is our MOSFET. Okay, na if you notice yung ating MOSFET, 'di ba? Sabi this is a four-terminal device. Usually yung bulk ayun or yung body connected lang yan sa ating substrate. And Yeah, if you notice, sabi dito, etong ating, saan na ba yan? Dito muna. Etong ating gate, again, insulated siya. Ano? This is just a metal conductor. Ito din po, metal conductor lang din naman to. Okay? But under that metal conductor, meron tayong, sa source, meron tayong N channel, meron tayong N-type material. Sa drain, meron din tayong N-type material. And you know naman N-type material, ano, from your electronics, yung mga N-type material, these are shall I say, extrinsic? Tama ba? Opo. Extrinsic materials, ibig sabihin, they are already doped para ma-increase yung kanyang conductivity. And yung abundant dito in this material are your electrons. Kaya nga po siya N-type material, di po ba? So, eto lang siya. Okay? Now, if you notice, if I'm gonna ask you, before that, itong N-type material, itong dalawang to, N-type material, they are separated by this P-type substrate. Okay, separated po yan. This is N-type, this is P-type. So basically, walang connection itong dalawa po. Okay? So, kasi sabi, di ba, yung MOSFET is just like a switch. So, ano lang siya? Para lang bagang merong connection, pwedeng magkaroon ng connection, your source to drain, pwede din namang wala. Depende po dito. Okay? So, if you look at this initially, kasi yung N natin at saka ito ding N-type din dito sa drain, yung source at saka drain, they're separated by this P-type substrate. So basically dito, walang connection. Okay? So if you think of MOSFET as a switch, as of this moment, kumbaga, it is off. Okay? So kasi di po ba pag switch merong nagko-control? Okay, so sino yung nagko-control? Ito po, yung gate. Okay, itong gate na walang connection sa kanila can control etong ano natin dito, connection. Kung magkakaroon ba siya ng connection or not. Okay? As also you have seen dun sa ating video. Okay. Now, sabi, 'di ba sabi, yung ating MOSFET is meron siyang N-channel. Asa na ba yun? Enhancement or depletion. Okay. So, itong enhancement or depletion, this one is an example of a enhancement type MOSFET. Enhancement because to create a connection, kailangan mo pang i-enhance, kumbaga yung dito, kailangan magkaroon ng connection kasi initially wala. Okay? Kailangan magkaroon ng connection, of course, para we can say that naka-on siya. Okay? And ito namang N channel or P channel, depende kung anong channel po yung mapoproduce niya dito. For this type of MOSFET, kapag ka na-connect, itong ating, later malalaman natin kung paano siya nag-connect. Pero kapag ka nag-connect itong ating source or and drain on this, pag nagkaroon ng connection, edi po ba nagkakaroon ng, edi po ba N channel po yung napoproduce? O, so, ayun siya. Kasi po, if this one is P-type, kung P-type, made up of P-type itong drain and source natin, of course, yung substrate natin is N-type, di po ba? Para walang connection. So, kapag ka ganun, and then, nagkaroon somehow ng connection dito, depende sa voltage na apply sa gate, eh, yung channel na produce eh, di po ba P-type? O, so, ayun siya. Okay? So, yung N-channel or P-channel na sinasabi dito, is depende kung anong channel po yung mapoproduce natin on this layer, kumbaga. Okay? Okay, so that is our MOSFET. Now, sinasabi na yung gate yung nagko-control sa ating connection between the drain and the source. So, tingnan natin ngayon, paano ba talaga? Or what are the criteria para mag-on siya? Alright, so let me introduce you to the term called threshold voltage. And I think, again, kasi MOSFET is part naman siya ng transistors. No? So, ano na lang, review na lang. So, naalala nyo before from your electronics na meron tayong tinatawag na threshold voltage or VTH. Tama po ba? Okay. Now, if applied on MOSFET, yung threshold voltage natin, sabi, ito lang yung level of gate to source voltage. Asan yun? Level daw yan ng gate to source voltage. Kasi di ba pag sinabi natin yung voltage, kailangan may dalawang point para maano natin yung potential difference between the two. Okay. So yung threshold voltage, that is just the level ng gate to source voltage that creates an inversion layer. Or yung inversion layer na sinasabi natin, ito yung channel. Itong sabi ko kanina nung nakaka-create, okay? That creates an inversion layer or channel is called threshold voltage. So, ayun. Yung threshold voltage, yun lang yung level ng ating gate to source voltage na enough para makakreate nitong ating inversion layer. Okay? Kumbaga, pag in-apply mo ng voltage itong gate to source na high enough, okay, high enough para ma-create itong channel na ito, yun yung VGS. Sorry, yun yung VTH. Okay? So, ibig sabihin, kapag ka yung VGS natin, yung gate to source voltage natin is less than the threshold na sinasabi, so wala ka pang layer dito. I mean, channel. Wala ka pang inversion layer dito. Pero kapag ka yung VGS mo, yung gate to source voltage mo, greater than the VTH, nagkakaroon ka na ngayon ng channel. Okay? Now, channel pa lang yan. Hindi pa, may current flow na ba? Wala pa. Okay? Channel pa lang. Possible pa lang siya na madaanan. Possible pa lang na magkaroon ng current flow. But basically, sa ganitong setup, wala pa po siyang current. So, paano na ngayon? For the current to flow, kaya nga nilalagyan ng channel, ano? Kasi ang goal natin, makapag-flow yung current. Di po ba? Kasi para switch siya, di ba? So, for the current to flow, VGS supplied must be able to provide a channel between the source. Ayun na yun. Okay? So, kailangan yung VGS dapat greater than the VTH para magkaroon po tayo ng inversion layer. Kasi pag wala to, pag ganito siya, less than the VTH, eh paano makakatawid yung ating mga electrons? Di po ba? Kasi electricity is just the flow of electron. So, kung wala siyang dadaanan, kasi this one is yeah, kung wala siyang dadaanan, eh di walang flow ng current. Okay, so kailangan yung VGS must be greater than VTH. Next, there must be a potential difference between the source and drain terminals. Kailangan din may voltage supply or potential difference between the source and the drain. Okay? Kasi again, dalawa yung tatandaan natin para may current na mag-flow sa ating Mosfet. Una, kailangan merong layer dito. Okay? Paano nagkakaroon ng inversion layer? Kapag kayong VGS is greater than VTH. Itong voltage between the gate and the source, dapat high enough siya para makakause nito. Okay? And then, kailangan din may magtulak sa mga electrons na to. Tama po ba? So, kailangan meron po tayong potential difference between the source and the drain. Diba? Kasi kung walang potential difference, walang magtutulak sa ating electrons na nandito. Di po ba? Oh, kung meron ngang magtutulak na ating electrons dito between, halimbawa, meron kang potential difference between your source and the drain, eh wala ka namang tulay dito, wala namang channel dito, eh wala pa rin current. Okay? So, kailangan itong dalawa mat-satisfy so that we will have current para magkaroon tayo ng current. Okay po? Okay. For an enhancement mode, NMOS, enhancement to, di po ba? Kasi kapag ka nagkaroon tayo ng VGS, nagkakaroon ng channel dito. Nang i-enhance, kumbaga. So, kaya enhancement siya. The VTH is positive. Yan. So, kailangan positive daw yung VTH. For an enhancement mode, pagka... Ay, nawala ako. Sorry. For an enhancement mode, NMOS, VTH must be positive. For an enhancement mode, PMOS, VTH must be negative. Kasi si MOSFET, meron tayong NMOS, PMOS. Okay, pag sinabi natin NMOS, ito na yung N channel. Okay, depende sa channel na produce. For this one, okay, say for example, this is N, kasi N to, N channel. Anong klaseng MOSFET to? N-channel MOSFET or simply NMOS. Okay po? Kapag ka P-channel naman to, that is P-channel MOSFET or simply PMOS. Okay? So most of the time, we'll be using the term NMOS and PMOS. Ayun. So sabi niya, for NMOS, the VTH must be positive. Okay, baliktad. Ano po? Pagka NMOS, kasi N-type to, kailangan positive daw yung VTH. Kapag ka PMOS ka, kailangan yung VTH mo is negative. Okay, remember yung relationship, they are baliktad. Okay, magme-make sense to mamaya kapag ka na-discuss natin sa baba. Bakit kailangan positive? Bakit kailangan positive? Sorry. Ba't kailangan negative? Ba't kailangan positive? Okay? Sabaw na sabaw eh. Okay, so let's proceed. So let's have the qualitative theory for our NMOS. Okay, so this is our N-channel MOS. Bakit nga N-channel? Kasi yung possible na channel na makikreate dito is N. Kasi nga yung ating drain source is N-type. Tama po ba? MOSFET. Is it enhancement or depletion? This is enhancement. Kasi initially, wala pa tayong connection. Tapos nabubuo lang siya. Naka-create lang siya. Na-enhance lang siya. Okay po? Okay. Okay. So, on this left ba to? Ay, sabaw. Yeah, left. On this left figure here, we have a common source configuration. Okay. Ma'am, ano na naman yan? Ba't naman tayo napunta na naman sa mga common source, common drain? Okay, so ganito lang yan. Basically, ganito kasi ina-employ yung ating NMOS. Okay, so imagine, etong drawing na to, eto lang po siya sa pag... Ay, nako, ano ba yan? Okay, again, imagine itong drawing na to, eto lang po siya sa schematic diagram. Okay? These are just equal. Eto lang, pinakita lang na ganito siya para at least ma-visualize nyo ano ba yung nangyayari sa loob ng ating Mosfet. Okay? Tingnan nyo. Ang gate natin, kasi 'di ba for current to flow kanina, una, kailangan yung gate to source, meron siyang um, voltage na greater than the threshold. Tama po ba? So, kaya dito, nilagyan niya ng, tinawag niya VG yung kanyang supply dito. Okay, nilagyan niya ng VG yung gate to source. Ito namang isa, second na criteria, kailangan meron tayong magtutulak ng electron. So, kailangan may potential difference between the source, the drain and the source. Kaya nilagyan niya po dito ng VD. Okay? So, ito yun. Kung titignan mo siya sa schematic. So, ito yung MOSFET. This one, itong colored na to, ito siya. And then sa gate niya, nilagyan ng VG. Asan yung gate niya? This one. So, meron siyang VG dito. Okay? And to the ground. And then, dito din naman sa ating drain, meron ka ding uh, yeah, voltage supply to the ground. Okay? So, eto na siya. So, basically, ganito yung magiging configuration ng ating NMOS such that magkakaroon ng current flow. Okay? So, if you notice, kapag ka ganito, di ba, ang tawag natin dyan, common source configuration. Bakit nga common? Kasi yung ating source, siya yung common to all. Tama po ba? Siya yung connected to the ground. Common siya sa lahat. Okay, so the study of qualitative theory of NMOS aims to gain an understanding of the transistor's operation based on its IV relationship. A voltage VD, a voltage VDS, itong VD or VDS, okay, is applied across the drain and the source in an attempt to make the current IS. Kasi ano nga yung goal nitong, kasi itong goal nito, magkaroon tayo ng enhancement or ng layer or ng channel dito, di po ba? Para magkaroon ng tulay. Ang goal naman nito is, ang goal naman nito is para magkaroon ng current between your drain and the source. Itong IDS. Okay? Para magkaroon tayo ng IDS. IDS because current yan siya from drain to source. Para magkaroon ng IDS, kailangan may VD. Okay? So, ibig sabihin, yung VDS, if VDS is greater than 0, IDS is also greater than 0. Kasi kung gaano kalakas yung magtutulak dito, depende din kung gaano kalakas yung matutulak. Tama po ba? Kasi potential difference is just the energy that pushes your electrons. So, mas greater yung energy na mag-push sa kanya, mas marami din siya mapupush. Ano po? So, yung gate voltage din naman, okay, aside from nagkakaroon siya ng tulay, yung quality ng tulay, kumbaga, yung conductive property ng channel o ng tulay, depende din po sa VG. Okay? So, hence, sa transistor, so, ibig sabihin, o, di ba, pag medyo lesser yung value ng VGS natin, pag medyo lesser siya ng VTH ng konti, hindi din ganoon yung kaganda, yung layer na mapoproduce na. Di po ba? So, ibig sabihin pala, in general, the transistor current varies according with the voltage applied to the terminals of the transistor. Okay? Yung current ng transistor, asan ba yung current na sinasabi natin? Itong IDS, depende po siya sa mga voltage na naka-apply sa ating transistor. Depende sa mga voltage na to. Okay? Naintindihan po? I hope so. Okay, so ganun siya. Now, titingnan natin kung paano ba talaga na-produce itong ating layer dito. Okay, so we have this next slide. So we have, again, continuation of the qualitative theory of our NMOS. Okay. So we have here, we had drawings, no? Two illustrations. So let's focus first on the first illustration. Tingnan natin, ano? So, sa first natin na illustration, yung VG sabi niya is less than 0. Okay? And yung VDS is 0. Wala po siyang nilagay na voltage dito. Meron ba tayong ina-expect na current? The thing pa lang, ano, na wala siyang VDS na nilagay dito, wala ka nang i-expect na current. Tama po ba? tingnan din naman natin sa ating, eto, meron bang tulay? Kasi, ganito ha, isipin natin, hindi porket may tulay, may tubig na dumadaan, may current. Okay? So, ganun siya. So, kahit may tulay dito, say for example, kung wala ka namang VDS, wala ka rin current. Kahit may current, kahit may tubig, kung walang tulay, hindi, wag na yun. Ang awkward, ang weird. Okay, so sabi, nilagyan na ng VGS which is less than zero. Less than zero, ibig sabihin negative. Okay? So, ibig sabihin, yung apply niya dito na voltage is negative. So, ano mangyayari kapag ka negative yung nilagay dito? Remember yung kanina, sabi, asa na yun? Sabi kanina, for NMOS, kailangan yung VTH is positive. For PMOS, kailangan yung VTH is negative. So, ito na yun. Malalaman na natin kung bakit. Okay, this is NMOS or PMOS? This is NMOS kasi N-channel po yung nagagawa. So, kailangan yung ating VGAs. Yung ating VTH is, anong sabi kapag ka NMOS? Positive. Now, what if nilagyan natin siya ng negative? Ang tigas ng ulo, ano? Sabi nga pagka NMOS, dapat positive yung VTH. Eto, what if negative yung ilagay natin? Anong mangyayari? Sabi, by placing a negative voltage at the gate, kapag ka nilagyan po yan ng voltage dyan na negative, holes are attracted to the channel region. So, etong mga holes, okay, kasi this is N-type, this is P-type. 'Di ba madaming holes dito kasi nga P-type, 'di ba? Oh, so itong mga holes dito, ito represented by this positive. Itong mga holes daw dito, kasi negative yung nilagay mo dito, ano mangyayari sa kanya? Like, anong tawag mo dito? 'Di ba? Meron tayong tinatawag na like repels and like attracts. Okay? So, meron ka mga holes dito or positive. Meron ka mga negative dito or mga electrons. Ano mangyayari? They are attracted. Tama po ba? Ma-attract sila sa isa't isa. So, ang mangyayari, itong mga excess dito ng mga holes, pupunta po dito. Okay? So, ayun. Do you think merong layer na napoproduce? Do you think makakadaan pa itong mga electrons natin dito? Papunta sa kabila, makakatawid pa ba siya? Hindi, kasi madaming P-channel, P-type dito, maraming holes. Okay? So, kaya ayun. Now, again, sa N-channel, kapag nilagyan mo ng negative yung iyong gate, wala ka pong channel na mapoproduce. Because the holes accumulate at the channel. Naiipon po dito yung ating holes, which makes it hard for this elect uh, electrons to flow from drain to source or source to drain. Or yung transistor natin becomes more resistive. Okay? So, ganun yung nangyayari kapag ka negative yung nalagay mo na VGS. Right? Now, ano namang mangyayari? And we don't want that, okay? I mean, not really we don't want, but kung gusto natin ng channel, ng conduction, ng current flow, gusto natin kapag ka N-type, positive yung ating VGS. Now, let us examine ano naman yung mangyayari kapag ka yung VGS natin is positive. Okay? So, same is true. Meron pa rin tayo ditong 0 pa din yung VDS. So, hindi pa po natin tinitingnan yung current flow as of the moment. Ano? Tinitingnan natin yung ating layer lang po muna. Okay. So, by placing small positive voltage at the gate, holes are repelled from the channel region. So, kapag ka positive ito, may positive dito na potential, and ito yung mga holes natin, ano ba nangyayari kapag ka like, di ba they repel? Okay. So, itong kanina, itong mga na-accumulate dito na mga holes, okay, nare-repel po sila. So, instead na nag-accumulate sila dito sa channel, andito sila sa baba. Okay, pumupunta sa baba. So, wala na sila dito sa gitna. And since wala na sila dyan, yung nangyayari, pwede na ngayon, tignan mo ha, the channel becomes depleted of the holes. So, nawalan na ng holes itong channel. And yung channel natin becomes N-type. So, nagiging N-type na yung ating channel. Okay. So, nagkakaroon na because nawala na itong holes, nagkakaroon na ng chance na magkaroon ng layer or connection itong ating drain and source. Kaya kung nakikita nyo, andito na yung mga negative, ano natin, Itong mga electrons, negatively charged particles. Okay? Kasi itong substrate din naman na to, somehow, meron din naman siyang electrons, ano. So, ayun, yung mga electrons niya napupunta dito because na-attract siya sa positive na to. And then, thus, allowing connection between the drain and the source. Okay? So, again, N-channel yung ating na-produce. So, again, this is only possible if VGS is greater than 0. Ibig sabihin, positive siya. And that VGS is... But if you notice, sabi dito, ano, ma'am, asan yung channel? Ba't wala pa? Di ba? Wala pa masyadong channel. Kasi, in this case, or this scenario is when VGS is less than VTH. Okay? Yes, positive siya, greater than 0. So, na-attract niya somehow yung mga negative charged particles dito. But then, hindi siya enough, okay? Hindi siya enough kasi yung VGS natin is less than the threshold pa. So, somehow, wala pang masyadong, wala pang channel talaga actually na nag-exist. Okay? Kasi again, hindi pa enough itong VGS na nilagay natin. Now, what if, lagyan natin ng positive, lagyan din natin ng VGS which is greater than VTH? What will happen? Ito po yung mangyayari. Okay? So, notice niyo po itong kanina, itong mga electrons dito sa ating substrate. Diba kanina nakaabang lang siya, pero hindi pa talaga siya nakatawid dyan po. Di po ba? Kasi hindi pa siya strong enough yung VGS. Hindi pa strong enough yung attraction. Once tinasan yung VGH, such that, malampasan niyo yung VTH, strong enough na yung attraction na itong mga nakaabang dito ng mga electrons, mapupull na siya dito sa ating channel. Okay? Mapupul na siya dito and somehow nakakaroon na tayo ng complete path. Okay? Nagkakaroon na ng layer ng electrons na complete na makakapag-flow. Possible na makakapag-flow yung ating current. Okay? So, yung ating electric field pulls the electron to the channel. Yung mga electrons dito na pupul niya into the channel, complete na yung ating path. Ano po? Pero somehow, again, tulay lang to, okay? Hindi ibig sabihin na may tubig lahat ng tulay. Ibig sabihin na may flow kapag ka mayroon ng channel dito. With no potential difference pa din naman, always remember, with no potential difference between the source and the drain, VDS is equal to 0, no current flows through the transistor. ID is equal to 0. Okay? So, ito na ngayon yung relationship ng ating IDS and our VDS. Alright? Now, if you notice, yung ating current when VDS, saan ba tong VDS? Assuming this one is for VGS is greater than VTH. Okay, assuming meron na tong tulay. Okay, ready na yung tulay. Kapag nag-apply tayo ng voltage, pagka dahan-dahan tayo nag-apply ng voltage, pataas ng pataas yung ating voltage, yung current din naman, dahan-dahan din siyang umaakyat. Okay, but then, after some point, ang tawag natin dito is VOV, after some point, somehow nasa-saturate na yung ating current. Hindi naman ibig sabihin na kahit taasan mo pa yung voltage mo, hindi na tataas yung current natin. Okay? Kahit taasan mo pa yung voltage, hindi na tataas yung current kasi limited lang siya. Kasi yung number of electrons, kasi yung channel natin, limited lang din. Di po ba? Para bang parang may tubo ka, tapos meron kang water tank. Kahit ang daming possible na tubig na pwedeng mag-flow, kasi limited lang yung dadaanan niya, limited lang yung tubo mo. Say for example, ayun, so hindi siya, nakokontrol siya. Okay? So, eto yung nangyayari. Nagkakaroon ng constant na ngayon, somehow, it goes through constant na yung current na nag-flow. Okay? So, ayun po yung ayun po yung nangyayari kapag again, VGS is greater than the VTH. Handa na po yung dadaanan. Depende na lang kung ilang current yung dumaan sa ating VDS. Okay, depende na lang sa push caused by the potential difference between the drain and the source. Okay. So, meron din tayo ditong, continuation lang din naman siya. Okay. So, ito daw yung IDS, ang naka-red. Ito yung IDS when VDS, drain to source, is greater than 0, but less than yung VOV. Okay. Kung baga, linear pa yung kanyang property. Okay. Habang pataas ng pataas yung VDS, pataas din yung current on this part. Okay, pero pagka na-reach na yung VOV, ayun, nagsasaturate na siya. Kasi ano bang cause itong saturation dito? Kasi doon nagkakaroon ng pinch off dito na side. Tingnan mo to. So, yung amount ng electron na magflow, nalilesen. Okay. So, in this case, yung channel natin acts like a resistor. So, ito po yung pinch off na sinasabi ko. Ito, nagkakaroon ng pinch off. Kaya, hindi siya totally linear yung nangyayari dito sa ating current flow. Okay? So, itong VDO naman, yung VOV, ito lang naman siya. That is just the VGS minus VTH. Okay? Yung VOV, that is just your VGS, yung VGS natin dito minus your VTH. Kapag kayong VDS na-reach niya itong VGS minus VTH, yung VOV, nagkakaroon na ng pinch off and thus saturated na yung ating current flow. Okay, so take note, sa ating NMOS or MOSFET, meron tayong length at saka width. Okay? Yun yung size ng ating channel kumbaga. Yung length, ito yung length ng channel tsaka width. Okay? Now ngayon, ang nangyayari, nagkakaroon ng changes dito sa length natin. Kasi as we increase our VDS, habang ini-increase natin yung VDS, anong nangyayari? Itong pinch off dito, it widens. Okay? Nagwa-widen siya. Increasing VDS further widens the depletion layer even more, and the pinch-off region also expands, extending the pinch-off further, causing the change in your length. Okay? So initially, di ba, ito lang yung length natin from here to here. And since in-increase mo yung voltage, ang nangyayari, nagkakaroon ng increase sa ating depletion layer and increase sa ating pinch-off, nagkakaroon ng additional length. Okay? So, yung L mo is hindi lang from here to here. Nag-i-increase siya. From here na siya ngayon to here. Okay? Okay, so we have here our common source. Yung common source, ito yung kanina ha. Yung ating common talaga na, yung configuration, normal configuration for our NMOS. Ito, common source configuration. For common source configuration, ito yung output characteristic niya. Ito yung VDS. Familiar na kayo ano yung VDS? Ito yung IDS. Okay? So again, ito, linear pa siya this time. And then, after sa VOV, nagsasaturate na siya. Di po ba? Okay. Now, if you notice, if VGS is held constant, yung VGS natin yung sa gate to source, kung constant yun, and then, say for example, at this level of VGS, okay, sa VGS 2, kung constant yon and in-increase natin yung VDS, eventually, magsasaturate yung drain current natin. Of course, magsasaturate siya dito. Okay? For a fixed VTH, the higher the level of VGS, the more saturation level of VDS or VDSAT as shown in the locus point of VOV. Natingnan natin ang nangyayari dito sa ating characteristic. Okay? Ito, in-increase yung ating VGS dito is less than VTH. Ano bang nangyayari? Of course, walang current flow. 'Di ba? Kasi walang tulay. Although, in-increase mo yung VDS. So, kaya cut-off region to. Off. Okay? Now, say for example, nilagyan natin siya ng VGS. Itong mga VGS greater than VTH. Okay? So, ibig sabihin, secured na tayo na meron na tayong channel. Okay? May inversion layer tayo. So, say for example, at this level of VGH, ito yung ini-increase din natin yung ating VTH, ito yung nagiging graph ng ito yung ating nagiging characteristic. In-increase pa natin, ito siya ulit. In-increase pa natin yung VGH, VGS, ito siya ulit. Same VDS ha. In-increase pa natin yung VGS, ito siya ulit. Now, if you notice, habang tumataas yung ating VTH, anong nangyayari sa ating mga VOV? Ayan, this is the locus of VOV. Anong nangyayari sa kanya? Dito kanina is somewhere here. Yung VOV dito na siya. Until dito. Our VOV is also increasing. Okay? So, habang tumataas yung ating VGS, yung ating VOV, okay, the point wherein bago mag-saturate yung ating current, pataas din ang pataas. Okay? So, ito yung mga laboratories natin for this subject. So, makikita nyo talaga to na nangyayari sa ating device when you will have your laboratory. Okay po? Okay. Bakit nga ulit? andito yung ating mga VOV? Kasi nga yung VOV, ano nga formula ng VOV? That is just VGS minus your VTH. Okay, so the greater the VGS, constant din naman yung VTH kasi this we're talking about um the same device here. So talagang nag-i-increase din yung iyong VOV. Okay? So eto po, tawag po natin dito sa region na to kasi naka-off yung ating MOSFET, walang tulay, walang channel, walang inversion, so cut-off region. Eto dito na side, eto is linear kasi 'di ba habang ini-increase mo yung VDS, nag-i-increase din yung current. Dito na side, hindi na po siya linear. Kasi kahit anong increase na ng iyong VDS, hindi na nag-i-increase ng ganoon talaga yung current. So, part na to dito, this is called the saturation region. This is the linear, this is the cutoff. Okay, so we have here our N channel versus our P channel MOSFET. Tingnan lang natin yung difference ng dalawa. Okay, so paano nga ito naging N-channel? Kasi yung channel na pwedeng possible na ma-produce is N-type. Ito na mga isa, yung channel na pwedeng ma-produce is P-type. Kaya ito ay P-channel. And both of them are enhancement. Okay, so same pa rin naman, meron din siyang drain gate source bulk, drain gate source bulk. And again, sa iyong P-channel or PMOS, yung substrate mo is kabaliktaran ng iyong channel. Okay, para magkaroon ng division itong dalawa. So, instead na P-type substrate, pagdating sa P-channel, N-type substrate po tayo. Okay? So, ito lang yung kanyang symbol. So, this is for your N-channel. This is for your P-channel. So, notice the difference sa symbol. Actually, marami tayong symbol for NMOS and PMOS. May isa na kapag NMOS, meron siyang bilog somewhere dito sa makikita nyo mamaya. Okay, but this one, yung difference ng ating symbol is itong isa for N channel. Ito yung, andito yung arrow. Di ba? Parang napasok na sa ating transistor. For PMOS, andito yung arrow. Pasok na pasok. Ganun. And also pala, itong bulk or ating body, kapag ka N-channel ka, N-channel, nakakonect siya kasi you will need this later on pag nagkaroon tayo ng laboratory, okay? Yung bulk, kinoconnect natin sa ground, sa N-channel. Kapag ka P-channel ka, yung body or bulk, kinoconnect natin sa supply or sa highest potential. Okay? Okay, so that's it for our video lecture for today, and I hope naintindihan nyo yung ating NMOS and PMOS, kung paano ba siya nakakonect. And then after this, you will have most probably after trial, no, you'll have your first laboratory. Okay? Okay, so that's it for now. Thank you for listening. See you on our next video lecture. Stay safe and God bless.